everyone, thank you for your interest and participation. My name is Süleyman Arıkan. I am working as a senior researcher at the Scientific and Technological Research Council of Turkey, abbreviated as TÜBİTAK, and I'm a PhD student at Gazi University. Today I'm going to talk about our study on cyber threat intelligence. This is a joint work with my advisor, Assistant Professor Sami Acar. In such a platform, I feel very lucky and happy to have this opportunity to introduce our work titled A Data Mining-Based System for Automating Creation of Cyber Threat Intelligence. Now, let's begin with the outline of this presentation. First of all, I will talk about cyber threat intelligence and our motivation. Then I'm going to introduce related work and main contribution of this paper. After presenting proposed system design, I will present details about implementation of the system. Subsequently, I am going to introduce the case study. In the end, I will talk about the conclusion. The cyber environment, which provides an infrastructure for easy access to all kinds of information and services, has become an indisputable part of human life. Public institutions, private companies, non-profit organizations, and individuals are taking steps to ensure the security of the cyber environment. Cyber threat intelligence has great importance for the success of these steps. Cyber threat intelligence, abbreviated as CTI, can be defined as the information required for the identification and detection of cyber threats or any kind of data that can be used to provide cybersecurity. With CTI, information can be acquired about current attacks as well as data about new or upcoming attacks. In this way, measures can be taken for them. CTI is divided into four groups. Tactical, technical, operational, and strategic cyber threat intelligence has been defined with this grouping made according to the information contained and the target audience of the relevant information. The tactical CTI is used for the information about the tools and methods used by the attackers. The technical CTI for the information required to detect the attacker or malicious software. The strategic CTI for the information about the financial issues or the attack tendencies, and the operational CTI for the information about the attacks that can be performed to organizations. Even though there are many advantages to using CTI, there are some difficulties in its production. For this reason, the problem in this study is defined and handled as the inconvenience of producing CTI and the inability of many researchers and/or institutions to produce CTI due to this inconvenience. Expert knowledge in the relevant field is required to produce CTI. In cases where sufficient expert knowledge is not available, CTI cannot be generated or may contain misinterpreted information. And also, in cases where expert knowledge is available, a very long and laborious working process is required, since almost all stages of CTI production include manual processes. In addition, there is no general similarity between the reports produced by intrusion detection systems. Therefore, the output of each IDS contains a different data model. When working with more than one IDS, the data model of each IDS report should be well known and CTI should be able to be produced with the information obtained from these different data models. This situation makes it difficult to generate CTI. CTI, which has to be created by users because it is not automatically produced by IDS, requires a vast workload, and the time allocated for this work is considered unnecessary by many companies and/or institutions. Within the scope of this study, the aim is to automate the manual steps used in CTI creation and to provide users with the ability to easily produce CTI without the need for expert knowledge. For this reason, a system has been proposed to facilitate the generation of CTI using data mining techniques. In this study, first of all, in the light of the information acquired from the literature survey, the proposed system and its modules have been designed. The system has been developed in line with the design and knowledge discovery in databases processes, including algorithms, have been implemented. With the proposed system, live or saved traffic records are classified according to previously learned attack types, and the cyber threat intelligence is produced in CTX format, which is a common standard. It has been shown that the results of the studies in the literature and the accuracy obtained through the Weka tool, which has proven its reliability in data mining, are similar to the results of the system. Then, the validity of the attacks in the preferred dataset was tested. With a case study classifying the saved traffic of a server exposed to the internet for 24 hours, it was shown that the proposed system can be easily used to successfully create CTI. Of course, the system has the ability to update the training set with new attack types by allowing unknown attacks to be identified with expert opinion. In some studies, it has been seen that the focus is on using data mining to produce CTI. Also, some research aimed to benefit from data mining techniques to improve the performance of intrusion detection systems. In both scopes, using various attack datasets and classification or clustering algorithms compared. When the studies in the literature are examined, it is seen that the focus is generally on specific algorithms or even a single attack scenario. On the contrary, our work covers multiple algorithms and it aims to classify various attack types. In some studies, the system was only proposed but not implemented. Conversely, in our study, a mature system that can be used as a product rather than just a proof of concept has been developed and its usability has been demonstrated. As far as we know, the main difference of our study from the similar studies in the literature and of course its contribution to the literature is that it proposes a system capable of performing analysis on live or saved real traffic records through data mining techniques to automatically create related technical CTI in a standard format. The format in question is STIX. In light of the information obtained from the literature survey, the design of the proposed system was realized by using 6 modules: storage, reporting, intrusion detection, network traffic listening, vulnerability simulation, and threat simulation. An overall summary of these modules and their integration is provided in the figure as a UML component diagram. A storage module is included in the design to implement the components encountered in the literature survey, such as data warehouse, security policy knowledge base, and database. The module with the database it can contain is used to keep the records needed to be able to use the IDS and to be able to produce the CTI. In this context, information such as intrusion datasets to learn attack types, parameters used in the data mining process, real traffic records used to generate CTI are kept on the relevant module. A reporting module is included in the design to implement the components encountered in the literature survey, such as generating reports according to the results of the configuration and decision-making mechanism. Therefore, the reporting module is used for hosting reporting functions and for configuration settings that the modules may need. In addition to all this module is used to access the intrusion detection module, to get expert opinion for unknown attack records, to view the obtained real traffic records, and to access the created CTIs. An intrusion detection module is included in the design to implement the components encountered in the literature survey, such as an expert system for analysis and decision processes, a model Poultier, a detector that classifies records using the build model. In this context, the intrusion detection module is used to perform intrusion detection system functions such as analyzing real traffic records. In addition to all this module performs operations such as updating the learning set in case unknown attacks that cannot be detected by performed analysis are determined with expert opinion, performing data mining process, updating the database with traffic records acquired in the suitable format by the network traffic listening module. A network traffic listening module is included in the design to implement the components encountered in the literature survey, such as data collection, data formatting, and sensor that obtain formatted records from raw network traffic. In this context, the network traffic listening module is used to collect live traffic records and to convert live and or saved traffic records in a suitable format for the intrusion detection module. This module performs processes such as extracting traffic information and creating new attribute values of the relevant traffic record using the extracted information. Subsequently, it saves the acquired traffic records in the storage module for processing by the intrusion detection module. Also, in order to process live traffic records, a gateway that passes all traffic over itself is configured on this module. The vulnerability simulation module and the threat simulation module are included in the design to generate raw traffic data for the attacks to be learned. The vulnerability simulation module is used to create an attack surface. It may contain vulnerable services or honeypot systems. The threat simulation module is included in the design to simulate an attacker and is used to generate attack traffic through the vulnerability simulation module. In this context, the threat simulation module can contain attack tools. With both threat simulation and vulnerability simulation, the proposed system gains the ability to generate traffic for known or unknown attack types. Thus, the system gains the ability to generate CTI for any desired attacks. Also, learning the unknown attacks by the proposed system can be provided through these modules. Intrusion datasets are used as a training set for an IDS to learn attack types. In addition, a part of a dataset can be used for testing purposes to measure the performance of an IDS. Therefore, the selected dataset is very effective for an IDS to successfully fulfill its mission and to measure its capabilities. In the literature survey, it has been observed that the difficulties of carrying out a rather laborious and costly study may arise when the researchers prefer the dataset they will create instead of the generally accepted pre-built datasets while choosing the dataset to be used in IDS applications. So, pre-built datasets that are likely to be used are examined. The datasets such as DARPA KDD99, DEFCON, Kyoto, NSL KDD, CICIDS, 2017, etc. have been analyzed. It was decided to use KDD99 and NSL KDD datasets because they are frequently used and generally accepted in the literature. And also, the new datasets are not error-free. In addition, 10% of the KDD99 dataset was used. Python programming language and Flask framework are used to develop mentioned functions. With this programming language, the system has been developed in line with the design and knowledge discovery in databases processes, including algorithms, have been implemented. The table lists the system resources for the implemented modules. The intrusion detection module and reporting module have been placed on the same virtual machine in order to facilitate the implementation. The average accuracy values are as seen. The proposed system seems to be as successful as Weka. After seeing the similarities of these achievements with the results of similar studies in the literature, there was a need to test the up-to-dateness of the attacks in the NSL-KDD dataset. For sweep attack, one of the simplest attacks in the dataset to perform was preferred. As a result of the analysis, it has been proven that the NSL-KDD dataset can be up-to-date, since Persweep attack was classified with 99.5% accuracy. Web servers and web-based applications are very popular attack targets, and they are of interest to attackers even if they are not a direct target. Since database systems and other services such as FTP, Telnet, and SSH are using with web applications, honeypot systems have been used to serve web pages and to simulate all relevant services and systems on the server to attract attackers' attention. Since more than one honeypot was intended to run at the same time, low-interaction honeypots have been preferred. FTP, HTTP, and HTTPS services have been implemented using Dioneer. CoreEye was used to simulate Telnet and SSH services, and CityKelephant was used instead of the PostgreSQL database. A server was opened to the internet by operating in the cloud with Amazon Web Services. Following this, all traffic coming to and from the server over the internet has been recorded for the first 24 hours via the TCP/dump program. 5,547 records were obtained from the saved traffic and the classification process was performed. The attack types of the NSL-KDD training dataset have been used in the classification of saved traffic, and the ID3 algorithm, which achieved better accuracy as a result of the comparisons made on the relevant test dataset, has been preferred. With the classification process, it was determined that malicious activities was carried out over 740 different IP addresses. Results are shown in the table. CTI has been automatically created in CTX format after the classification process. Our main goal of the study is to minimize the difficulties in creating CTI. In this study, the system consisting of 6 modules has been designed and implemented. In addition, a case study was carried out on the application of the proposed system. The limitations of this study are as follows. The scope of the CTI created by the proposed system is limited to technical CTI, and the cloud service used for the server exposed to the internet may have blocked some malicious traffic. As for our future work, we aim to add the capability of examining IPv6 traffic to the proposed system design and to create new and up-to-date intrusion datasets. Thank you for your time, and please do not hesitate to contact us if you have any questions.